There is a specific quality to the airspace above the Eastern Front when a Russian Buk-M2 is operating in the sector. Ukrainian drone operators feel it in the restrictions placed on their flight profiles. The altitudes they cannot use, the approach angles they must avoid, the sectors that are designated as high risk because a medium-range surface-to-air missile system is actively scanning for exactly the kind of targets they are flying. The Buk-M2 does not need to fire to constrain Ukrainian operations. Its presence alone, the knowledge that its radar is active and its missiles are ready, shapes what Ukrainian forces can do in the airspace above the contact line. Days ago, that changed. Ukrainian reconnaissance drone operators, working a patient 3-day surveillance operation against a target that Russian crews had been moving carefully to avoid exactly this outcome, found the Buk-M2 that had been constraining Ukrainian drone and aviation operations in a sector of the Eastern Front. They tracked it. They prepared the engagement, and when the system stopped for a maintenance period in a concealed position, Ukrainian FPV operators struck the launch vehicle and the radar vehicle simultaneously, removing from the battlefield, in a matter of seconds, an air defense system that had been shaping Ukrainian operations for weeks. What followed was visible to every Ukrainian drone operator in the sector within hours. The airspace that had been restricted opened. The angles that had been avoided became accessible. The sector that the Buk-M2 had been defending with its presence alone was suddenly a sector where Ukrainian forces could operate at altitudes and profiles they had been denied. This is the story of how that happened. And this is what Russia lost. The Buk-M2 is not a new system. It has been in Russian service since the mid-2000s, representing an upgrade over the original Buk that entered Soviet service in the 1980s. But its operational relevance to the current conflict is immediate and significant. The system carries 4 ready missiles on its launch vehicle, a radar suite capable of tracking multiple targets simultaneously, and a range and altitude envelope that covers the drone platforms and low-altitude aviation assets that have become central to both sides' operations in eastern Ukraine. A single Buk battery, 1 command vehicle, 1 target acquisition radar vehicle, and several launch vehicles can create a defended zone of airspace that forces Ukrainian drone operations to adapt their profiles, their altitudes, and their approaches in ways that reduce their effectiveness. Ukrainian forces have adapted to operating in Buk-threatened airspace throughout this conflict. The adaptations are real, but they are costs. Longer approach routes that avoid radar coverage, lower altitudes that reduce observation range, flight profiles that accept higher risk from other Russian air defense assets in order to avoid the Buk's engagement envelope. Every Buk that Ukrainian forces destroy eliminates those costs in its coverage sector and restores operational freedom that Russian air defense has been constraining. The identification of this specific Buk-M2 began with a pattern analysis that Ukrainian intelligence had been conducting on Russian air defense positioning in the sector. Russian air defense systems are not static. They move to avoid Ukrainian counter-battery and strike operations, to maintain unpredictability, and to position themselves in relation to the threat they are assigned to defend against. The movement pattern of a Buk-M2, the positions it uses, the timing of its relocations, the relationship between its movement and the flight activity of Ukrainian assets in the sector, creates a signature that over time allows experienced Ukrainian analysts to identify the system even when it is not actively emitting. The 3 days of surveillance that preceded the engagement were not 3 days of continuous direct observation. They were 3 days of building the pattern from multiple collection sources: electronic intelligence, monitoring the system's intermittent radar emissions, drone observation of vehicle movements in the area where the system was assessed to be operating, analysis of the correlation between airspace restrictions imposed by Ukrainian command and the probable coverage zone of the identified system. The picture assembled from these sources became specific enough by the 3rd day to support the engagement planning. Ukrainian FPV drone operators do not normally engage Buk systems directly. The Buk-M2's own air defense capability, the ability to engage incoming threats including drones, makes a direct FPV approach a high-risk proposition. The system's crew, if alert and operating their systems actively, can identify and engage an inbound FPV drone before it reaches lethal range. The engagement in this case succeeded precisely because the surveillance operation had identified a moment when those conditions did not apply. A maintenance period, with the radar system in a non-operational mode, with the crew focused on technical work rather than air defense operation, in a concealed position that the crew had assessed was secure. Security assessments that are wrong are the recurring weakness in Russian air defense operations in eastern Ukraine. Russian crews have to balance the need for operational concealment, staying off radar emissions to avoid Ukrainian electronic targeting, with the need for tactical awareness, running their systems to maintain observation of the threat environment. The balance they strike, and the moments when that balance tips toward reduced vigilance, is what Ukrainian surveillance operations are specifically designed to find and exploit. The Buk-M2 crew that was maintaining their vehicle during the mid-April morning had run their system through multiple relocations over 3 days without being successfully engaged. They had reason for confidence. They had executed their shoot and scoot equivalent: move, establish, emit briefly, move again, with the discipline that had kept them alive through the preceding weeks. What they had not accounted for was the accumulated picture that Ukrainian surveillance had built across those 3 days. A picture precise enough that their maintenance position was identified not through active radar emission tracking, but through the pattern of everything that had preceded it. The strike package was specific to the target: 2 FPV drones assigned to simultaneous engagement, one targeting the Buk-M2 launch vehicle and its ready missiles, one targeting the radar vehicle that was the system's eyes and its most technically irreplaceable component. The simultaneous engagement was critical. Striking the launch vehicle alone leaves the radar intact, and a radar vehicle still provides targeting data to other air defense systems in the area. Striking the radar alone leaves the missiles ready to be transferred to a replacement launch vehicle. Destroying both simultaneously eliminates the system's operational capability completely and removes the possibility of partial recovery. The approach profiles for the 2 drones were planned to converge on their respective targets from different angles, reducing the probability that the crew of either vehicle could observe both incoming drones simultaneously and take evasive action. The launch vehicle drone approached from the south. The radar vehicle drone approached from the east. The timing was coordinated so that both reached their targets within seconds of each other. The launch vehicle strike ignited the ready missiles. The detonation of 4 surface-to-air missiles simultaneously, their solid propellant rocket motors and high-explosive warheads all cooking off together, was a secondary explosion that Ukrainian drone operators monitoring the engagement could observe from kilometers away. The radar vehicle strike hit the antenna assembly and the processing equipment that constitutes the system's operational value. The radar vehicle burned without secondary explosions, but with the sustained fire of electronic equipment and vehicle fuel that represents the destruction of hardware that cannot be easily replaced. The Buk-M2 battery that had been constraining Ukrainian drone operations in the sector was gone. Now let us examine precisely what Russia lost. The Buk-M2 system, in the configuration typical of Russian deployments in Ukraine, comprising a launch vehicle with ready missiles and a radar vehicle, carries a combined replacement cost of approximately $80 million to $120 million USD for the full battery. The individual launch vehicle with its 4 ready missiles is estimated at $15 to $20 million. The 9S-36 target acquisition radar vehicle, the component that gives the system its operational capability, and whose destruction is the more significant loss, carries an estimated value of $25 to $35 million. Additional associated vehicles and the command and control element add to the total. The 4 Buk-9M317 missiles destroyed when the launch vehicle's ready ammunition detonated represent an additional $8 to $12 million in missile costs. Each 9M317 missile carries an estimated unit cost of $2 to $3 million. Total direct material cost of this engagement, conservatively between $48 million and $67 million USD for the destroyed vehicles and missiles alone. But the direct replacement cost understates the operational significance of the loss. The Buk-M2 system contains sophisticated electronic components, the radar signal processing systems, the fire control computers, the electronic warfare integration that allows the system to operate in a contested electromagnetic environment that are precisely the categories of electronic component most affected by Western export controls and the sanctions regime that has been constraining Russian defense industrial access since 2022. Replacing the radar vehicle in particular requires electronic components that Russia's domestic production cannot fully substitute, and that the sanctions environment makes difficult to acquire through alternative channels. Russia's air defense industrial base has been under sustained pressure throughout this conflict. The production of new Buk systems and the manufacture of the specialized radar and electronic components they require is constrained by both the pace of combat losses and the component availability challenges created by sanctions. Every Buk system lost in Ukraine is a reduction of a capability that Russian industry is struggling to regenerate at the required rate. The operational impact of this specific loss extends across the sector where the Buk-M2 had been operating. Ukrainian drone operators, who had been flying restricted profiles to avoid the system's engagement envelope, can now operate more freely. Reconnaissance missions that had been conducted at reduced altitudes, accepting degraded observation quality in exchange for reduced exposure to the Buk's missiles, can now be flown at altitudes that provide better observation. Strike missions that had been routed around the system's coverage zone can now use more direct approaches. The cumulative operational benefit of restored airspace freedom in the sector is difficult to quantify, but is real and immediate. The personnel who operated the Buk-M2 were specialists. Russian air defense crews, the operators who manage the radar, the fire control personnel who conduct target engagement, the commanders who make the complex decisions required to operate an active air defense system in a contested environment without causing fratricide against Russian aviation, represent years of specialized training. The mid-April air defense engagement is not a course available to general infantry conscripts. The personnel lost with this system cannot be replaced by mobilization. They can only be replaced by diverting trained air defense specialists from other units, creating capability gaps elsewhere when they are moved. Ukrainian reconnaissance drone operators spent 3 days building the intelligence picture that made this engagement possible. Ukrainian FPV pilots flew coordinated simultaneous approaches against 2 separate high-value targets in a defended area. The result was the elimination of an air defense system that had been constraining Ukrainian operations in its coverage sector for weeks. The sector where the Buk-M2 was operating is now a different operational environment. Ukrainian drones fly at altitudes they were denied before. Ukrainian reconnaissance operators have angles and profiles they could not safely use. Ukrainian strike missions have approaches that were previously in the engagement envelope of a system that no longer exists. Russia built an air defense bubble in eastern Ukraine. Ukrainian drone operators found it, tracked it, and popped it. Ukraine clears the sky. Ukraine restores its reach. Ukraine holds the ground beneath the airspace it has reclaimed. To fully appreciate what this engagement means operationally, it is necessary to examine the specific relationship between air defense systems and drone warfare on the Eastern Front, because this relationship is less understood by outside observers than the tank battles and the infantry engagements that generate more dramatic footage, but it is equally consequential for how the conflict develops. Ukrainian forces have made drone operations central to their military effectiveness throughout this conflict. Reconnaissance drones provide the observation that makes artillery accurate. Strike drones, particularly FPV platforms, provide precision fires against individual vehicles and positions at a cost per engagement that no other weapon system can approach. Logistics drones are increasingly used to move supplies to forward positions under fire. The entire Ukrainian warfighting system, from intelligence collection through fire's execution to command coordination, has been built around drone availability in ways that make drone operational freedom a prerequisite for effective Ukrainian military performance across the full range of ground operations. Russian air defense commanders understand this. The deployment of Buk systems, Tor systems, and other medium and short-range air defense assets to the Eastern Front is explicitly intended to contest Ukrainian drone operations, to force Ukrainian operators into the flight profiles and altitudes where Russian countermeasures can degrade their effectiveness, to increase the attrition rate on Ukrainian drone fleets, and to create defended zones where Russian ground forces can operate with reduced exposure to Ukrainian drone reconnaissance and strike. When a Buk-M2 is operating in a sector, every Ukrainian drone mission in that sector must account for its coverage zone. Mission planners calculate the system's maximum engagement range, approximately 45 kilometers for the 9mm 317 missile, and the minimum engagement altitude. The system can engage targets at altitudes from a few dozen meters upward and design missions that stay outside those parameters or accept the risk of operating within them. For reconnaissance missions that need specific angles and altitudes to observe specific targets, the book's coverage zone may make the mission significantly less effective or force a level of risk that Ukrainian command is not willing to accept for routine operations. The practical effect of a Buk operating in a sector is therefore not simply the missiles it can fire. It is the cumulative reduction in Ukrainian drone operational effectiveness across the entire coverage zone. The mission's not flown, the altitude's not used, the observation angle's not achieved, the strike opportunity's not taken because the approach required crossing into the system's engagement envelope. This suppression effect is the primary operational value of the Buk, and it operates continuously regardless of whether the system fires a single missile. Destroying the Buk-M2 does not just eliminate the missiles. It eliminates the suppression effect. It removes the constraint from Ukrainian drone operations across the entire coverage zone, restoring full operational freedom to the Ukrainian forces that had been adapting to the system's presence. The 3-day surveillance operation that preceded this engagement was specifically designed to find the maintenance window that would create the conditions for a successful FPV engagement against a system capable of defending itself against exactly the kind of drones used to attack it. This is a targeting problem that has no simple solution. You cannot engage an active, alert Buk-M2 with FPV drones under normal circumstances because the system's radar will detect the incoming drones and the crew will engage them. The solution is to find the moments when the system is not active and not alert, and the only way to find those moments is through sustained surveillance that builds a pattern of life picture precise enough to predict them. Ukrainian intelligence operations against Russian air defense systems have developed this capability through operational experience. The specific indicators that suggest a Russian air defense system is entering a maintenance period, changes in radar emission patterns, the arrival of logistics vehicles, specific crew behaviors observable from drone altitude, have been cataloged and incorporated into the surveillance protocols that Ukrainian analysts use when tracking high-value air defense targets. The 3 days of surveillance conducted against this Buk-M2 applied exactly those protocols, building the picture that identified the maintenance window that became the engagement opportunity. The simultaneous strike against launch vehicle and radar vehicle represents the mature development of Ukrainian FPV employment against complex multi-component targets. Earlier in the conflict, Ukrainian FPV strikes against air defense systems often targeted the most accessible component, frequently the launch vehicle, without achieving the simultaneous destruction of the radar that would complete the system's elimination. Russian crews learned to relocate radar vehicles quickly when launch vehicles were struck, preserving the system's most irreplaceable component even when the missiles and launch platform were lost. Ukrainian operators have adapted. The coordinated simultaneous approach, 2 drones, 2 targets, synchronized timing, different approach angles, was developed specifically to deny Russian crews the opportunity to execute that partial preservation response. Both components struck within seconds. Neither crew had time to react to the other's strike before their own vehicle was hit. The approach angle coordination is technically demanding in ways that extend beyond simple drone piloting skill. 2 operators flying toward different targets in the same geographic area must manage their approach profiles so that neither drone interferes with the other's video feed or control link, so that the timing of their respective arrivals at target is genuinely simultaneous rather than sequential, and so that the smoke and debris from the first strike does not obscure the second operator's terminal approach. These are coordination problems that Ukrainian FPV teams have worked through in training and in previous operations, developing the procedures and communications protocols that make simultaneous multi-target engagement against a single system reliable rather than improvised. The crew of the Buk-M2 had operated their system with genuine professionalism. 3 days of disciplined movement, careful emission control, and systematic position changes had kept them alive and operationally effective through a period when Ukrainian forces were actively trying to find them. They were good at what they did. They made one mistake. They stopped moving for long enough that 3 days of Ukrainian surveillance could build a picture. And they stopped in a position that their maintenance requirement dictated rather than one they would have chosen purely for tactical security. That is the nature of the contest Ukrainian surveillance operations are designed to win. Not to catch Russian crews making obvious errors. To accumulate enough information to catch them making the small compromises that operational necessity eventually forces. The maintenance stop that takes slightly longer than planned, the position that is tactically adequate but not optimal. The moment when the pressure of keeping a complex system operational outweighs the pressure of maintaining perfect mobility. The Buk-M2 that had been limiting Ukrainian drone operations in its sector is gone. The airspace it had been defending is now accessible to Ukrainian operators at the altitudes and profiles that provide maximum effectiveness. Ukrainian reconnaissance missions in the sector can observe targets they were previously denied. Ukrainian strike missions can use approaches they were previously forced to avoid. Russia deployed a $60 to $100 million air defense system to eastern Ukraine to constrain Ukrainian drone operations. Ukrainian forces spent 3 days finding it and seconds destroying it. The constraint is gone. The freedom of operation is restored. And the front that the book was helping to defend is now a front where Ukrainian drones fly without the restrictions that system imposed. Ukraine clears the sky above its land. Ukraine holds the ground below it. And in the sector where the book burned, Ukrainian drone operators are now flying at altitudes they had not used in weeks. One more dimension of this engagement deserves to be stated plainly. The dimension that connects the destruction of a specific air defense battery to the daily survival of the Ukrainian soldiers on the ground beneath the airspace it was controlling. Ukrainian infantry and defensive positions on the Eastern Front depend on drone reconnaissance for their survival in ways that are direct and immediate. The drone that observes a Russian assault forming up before it moves gives Ukrainian defenders the preparation time that saves lives. The drone that corrects artillery onto Russian vehicle concentrations before they can reach Ukrainian positions is the reason Ukrainian soldiers are alive when those vehicles are destroyed at range rather than at the wire. The FPV drone that engages Russian soldiers who have broken into a position is the difference between a position held and a position lost. When a Russian Buk-M2 restricts the altitudes and profiles that Ukrainian drone operators can use in a sector, every one of those life-saving functions becomes less effective. Lower altitude reconnaissance provides shorter observation ranges. Restricted approach angles reduce the efficiency of FPV strike missions. Artillery correction drones flying degraded profiles produce less accurate fire missions. The soldiers in the positions below pay for each of those degradations in increased risk. In the assaults that had more preparation time, in the vehicles that got closer, in the positions that were harder to defend. The Ukrainian operators who destroyed the Buk-M2 may never know the specific soldiers whose situations improved when the system burned. The connection is real, but it is distributed across the entire sector and the entire period during which Ukrainian drones now fly more freely. 3 days of surveillance, 2 FPV drones, $60 to $100 million in Russian air defense hardware gone, and a sector of eastern Ukrainian sky that belongs to Ukrainian operators again. Ukraine clears the sky. Ukraine holds the ground. The front beneath the freed airspace holds with it.